September webinar entitled Spot Color Management and Wide Format Inkjet. While we're waiting for people to join, there is a poll question available up on the screen. We welcome you to go ahead and answer that just to give us a little more insight into where everyone is at with Spot Color Management today, and also to help us determine what topics we should cover in future webinars. Also, if you are joining us today, we are going to be tweeting out during the webinar this afternoon using the hashtag validation. So if you'd like to follow along via Twitter, we welcome you to do that. Once you're done with your poll, go ahead and close that at the end, and we will share those results with everyone. Let's go ahead and get started. My name is Mike DiCasola. I am the Chief Technology Officer here at Finite Color. I have a background of about 20 years in color management and color matching specific to Inkjet. So hopefully I'll be able to present some things worth listening to today. If you have any questions, my email address and phone number on the screen there. Feel free to reach out to me and ask a question if you want. Also, if you'd like to ask a question during the webinar, we'll be taking questions at the end. You can go ahead and state your question in the chat window, which is on the lower left-hand side. Go ahead and type that in. It won't publicize to everyone. It'll come just to me, and then at the end, we'll go through whatever questions have come up during the presentation. So again, welcome and thank you for attending today. The agenda for today is really almost kind of a continuation from last month's webinar, where we talked about why color was important in large format inkjet display graphics production. A lot of times we hear that pleasing color is good enough when it comes to inkjet production work, as opposed to commercial graphics or things like that. And we kind of took that myth apart and talked about why accurate color matching is very critical to inkjet production work. And we brought up spot color management somewhat in that webinar. And today we're going to take that and drill down into it in a little bit further detail. So you may see a theme here emerging on spot color management and how to manage customer logo colors and very critical colors when it comes to display graphics production inkjet. So the first thing we're going to do is drill into a little bit more of what is a spot color exactly. We'll talk about some challenges. Again, some things we covered last month, but a little more specific detail into some of the challenges that you see. And then we're going to spend quite a bit of time going through a test case where I spent some time this past week going through and trying to get some very critical close color matches to an actual Pantone guide. So let's start with what is a spot color. It's important to remember that spot colors were invented not for digital originally, but for conventional printing where we had an ink that we were going to use to print. So many people are familiar with Pantone. It's the most popular matching system out there. And it's important to remember that while Pantone is used universally as a design tool to help select colors and communicate colors throughout a workflow, and of course we see that in digital today, originally was invented as an ink mixing system. So in the 1960s, Pantone kind of took a step forward from where they had been in the past, and they had figured out a way to mix all the colors that you see in a Pantone fan book using 14 colors, 13 colors and one additional color, black. And so it was designed to be a single ink color. So a color that could be, you could simply load the ink into a printing press and print it and know that the color was going to be both consistent and accurate, as opposed to mixing with CMYK. So this creates kind of a dilemma for us when we think digital, because spot colors by their very nature are defined as a single ink color, not a color mixed from inks such as CMYK. But yet when we go into digital, we know that for the most part, 99% of the time in digital, any color we reproduce is going to be a mixed color, a color that is mixed from multiple inks, typically CMYK, but of course we all know that many of the inkjet printers now have expanded gamut systems where perhaps they add a red or a green or an orange into that system to get a larger gamut. So there are all sorts of different systems that are used to specify these colors that designers use. The designers put those into a file. They show up on our countertop when we're going to go ahead and print these digitally. And we have to figure out how do we get past this challenge of a single ink system going to digital. Kind of as a way to kind of exemplify that additionally, or to talk about it a little bit more, when we dig into what a spot color is and how it's defined, you'll hear people use the term named color. So a spot color can also be defined as a named color. And the reason for that is because the only thing that's really a color specification when it comes to a spot color is its name. So when I say to you, I want a spot color PMS 261, that's a green. Everyone knows that if you go to, 361 is a green. If you go into the Pantone guide, you look at 361, sure enough, there's a green. But digitally, when I define that in a file, even though it may say Pantone 361, there's no color actually attached to that object. And it's easiest to understand that idea when we look at, again, the traditional printing world. So if we had a named spot color as a printing plate, there'd be a big square there that really has no color defined. The only way that we define the color is when the press puts the ink into the ink train itself and says, oh no, that's going to be a red, it's going to be a blue, it's going to be a purple. So the definition is really just a definition by name, and that's where we get this concept of a named color. Well, what about in a digital world? Does that translate as well from a traditional world to a digital world? And we find it does. Here's an example of where I'm in Illustrator, probably the most used application when it comes to laying down spot colors or creating designs that have spot colors in them. And here you can see that I've opened up Pantone Warm Red in Illustrator, and over on the right-hand side, you see the Pantone palette where it looks like it should, and the top square was defined with that patch. But then I simply duplicated it, and I'm changing something underneath. I'm changing the color from a red to a green. I'm going to talk about what that is in a second, but that color mode, LAB, it's something known as the alternate color space. So in this case here, I can have something that has a name, Pantone Warm Red, but what I put in for that name can be something completely different. So it's possible to have a Pantone Warm Red that actually is defined as green. So how are these defined? I mentioned, or I showed you that Illustrator option where we were looking at the spot color in Illustrator. And it's important to think of a spot color as having two definitions when we define it digitally. The first one is the name. And so that name is going to trigger in certain workflow applications downstream when we go to print a file, such as, for example, a large format inkjet RIP that's driving an inkjet printer. That name triggers typically a lookup in a library. So if I say that, again, I have in this case, I have a Pantone 199 in there, and I have some different variations there. If I have a Pantone 199, that definition, that named color goes into the RIP. The RIP says, oh, I know what Pantone 199 is. It goes to this lookup table, this library that says 199 is defined in this way in this RIP, which then gives you some result in the printer. Now, we don't always send digital files to workflows that are spot color aware workflows or workflows that have libraries that match up with all the spot color names that we may use in our digital file. And because of this, every spot color that's defined digitally, let's say, for example, as we're showing here in Illustrator, also has an alternate color space assigned to it. And what the alternate color space is kind of a fallback option. So if I send Pantone 199 to a RIP, and that RIP doesn't have a lookup table, or if I print it through a driver, which by definition really doesn't have a library built into it of spot colors, then the application that's trying to print something will go to the alternate color space. And that's what we see here in Illustrator. So in Illustrator, if I load the Pantone 199 palette from the built-in Pantone library, we'll see that it's not editable. I won't have access to anything underneath. But if I make a copy and change the name like I've done here, here's Pantone 199 as an edit, and then we see that we have Pantone 199 in CMYK mode here. By changing the name, I can edit the alternate color space. And so in this case, I took the alternate color space and chose LAB, which is really the best way to define a spot color colorimetrically. And in this case over here, I chose the alternate color space as CMYK. So if these two different definitions went through a workflow that did not have a library to look up based on the name, in this case, over here with the LAB alternate color space, that is what would be used instead of the named library lookup. And this spot color here would use this CMYK value instead. And there are all sorts of alternate color spaces that you can use in an application like Illustrator. By the way, not many people know this, but the current version of Creative Suite, Illustrator in Creative Suite, by default uses LAB as an alternate color space. That's important to note because some RIPs and workflows don't support LAB as an alternate color space, which can cause some problems for you. Normally out of Illustrator, we export our files as PDF. And when you export them as PDF, we now have a document that is defined using the PDF specification. And it might be interesting to see how a PDF actually defines this color. So I took the test file, which I was using here for this webinar with my Pantone 189 CMYK and my Pantone 199 edit, and I saved it out of Illustrator as a PDF, and then opened the file in Acrobat Pro and did a pre-flight on it to inspect all the objects. And here we see that in Acrobat, these colors are defined as a separation color space. We see the name in quotes, and then we see the definition of the alternate color space. So here you can see that two-part definition that we talked about. The named color, which really has no color to it, it's just a name, it's a bunch of text. And then an alternate color space that does have some sort of color definition to it, okay? So that's how that works. And again, if you have any questions, if what I'm talking about isn't clear, please use the chat window to go ahead and ask a question as we go through this. So when we take that color, that spot color that is digitally defined with a name as its first primary specification and then as an alternate color space, what happens to that color as it goes through a workflow from the original concept all the way through to a digital print in Inkjet? Well, sometimes the way that'll originate as a customer specification. So a customer might come to you and say, well, I would like Pantone 155. I would like Pantone, 151, which is an orange, or Pantone 199, which is a red, which we were just looking at. May give you an LAB value of some sort and say, well, Pantone color, but this is the LAB that I want. And then from that, you may also have a printed book. So someone says to you, again, I have a 199 red, that's my specification. Well, then you can pull out your physical printed Pantone guide and look at that 199. And from what that guide affords you is a visual standard to look at to say, well, that's the color that the customer is expecting. We then have that color defined digitally. So again, that was what we just saw in Illustrator, where I might just pull something out of the Pantone library and it's just defined with a 199 name. And again, in Illustrator with an LAB alternate color. If I print that through a RIP system, often a high-end inkjet RIP will have a Pantone library built in, so that 199 name will get picked up by the library and it will be replaced with some custom color specification that was developed specifically by that RIP manufacturer. If I print through a driver, what's going to happen is the alternate color space is going to get picked up at all times, in this case LAB. It would then get converted into sRGB, which is the default color space of most drivers, and then from sRGB into the printer space when it prints. And you can see that's the last step there, that conversion to either an ICC destination profile, which is in the case of a RIP typically what's going to happen. But in the case of the driver, it's typically an internal lookup in the printer itself. So when we see all these components that come into play, all of these things, every one of these pieces of the spot color management system, all are places where we have the potential for something to go wrong or something to not be accurate. So when I look at that and I look at my specific example that I'm going through, what are some of the challenges in that many component system where, I guess a good way to explain it would be, or a good way to kind of look at it is, where are the weakest links in all those components? One of them is going to be your original Illustrator file, or your original Pantone color that's been defined in Illustrator to raster. And that is typically the path of a driver. So I have this square of color. In this case, on the screen, I have a Pantone 151 orange up there, and I'm going to take that 151 orange. I'm going to print it through a driver, and if I print through a driver that is CMYK, what kind of result would I get? If I print through a driver that's RGB, what kind of result will I get? And the thing that's very interesting is right out of the gate, I can go into Photoshop and kind of simulate the CMYK and the RGB driver scenario here, and you'll see that the LAB value, which was the original value I had for 161 of 70, 47, and 79, when I go to CMYK, it was changed to 66, 40, and 67. So just going from the original specification into CMYK, that very first step before I go into the printer, I've already lost accuracy in what the system believed I was trying to hit. Same thing with RGB. Interestingly enough, RGB did a better job where I went from a 70, 47, 79 to a 68, 44, 74, so much closer. Also, there's some other things to keep in mind, or some other areas that I think are interesting here. Again, I have 3 spot colors here that I used for my tests. One is a 199 red at the top, the 151 orange, 199, 151, and a 646 blue. And I looked at the LAB value that was being reported as the alternate color in Illustrator, and then compared that to an actual spectrophotometer measurement of a physical Pantone book that I have in my possession. And what was interesting is if you look at the top one, both the Illustrator LAB and the book measured values are extremely close to one another. That's good. But then as we go down, we see that it's worse. So the 151 orange is not so bad. It's really the A value that's the most different, the A and the B value, 47 to 44. And also when we look at the B value, sorry for my inconsistent ability to draw there, I go from a 79 to a 76. On the blue here, though, we see some really big changes. The L star goes from a 55 to a 52, and a negative 28 to a negative 30. So again, the difference between what Illustrator thinks the LAB should be for these spot colors and what the actual book is a large difference. We also see that same scenario happen when we look at what the internal RIP library is using to define the spot color as compared to the book that I may visually be trying to match. We've got a graphic that'll show that scenario here in a few slides. So let's talk about the test case. So what we did is we used Adobe Illustrator, the file at the right, which has a number of spot colors defined as the original Illustrator LAB, or the Illustrator defined named colors on the left, an editable column of those same colors, just defined as a different name spot color so that we can change the LABs. And then on the right-hand side, the same colors again, where the alternate LABs have been changed to match the Pantone book itself. So that's the file we're using. I used an EFI Fiery XF RIP, a Pantone solid coated guide, the X-Rite exact spectrophotometer to measure the delta E difference between the book and the print. We did some iterations with the finite color calc tool. We used an HP DesignJet 6100 and validation 260 semi-gloss media. The reason we chose a semi-gloss photo media is we wanted to be able to show what spot colors, what we could do with spot color management when we had a large enough gamut to at least hit most of the spot colors that we were trying to hit here, or at least using as our example. And so our goal through this test case was to match the print coming off the printer visually and numerically to the Pantone book. That was what our goal was when we set out. So again, we defined these in Illustrator. We did do a print through a driver just to see what kind of results we would get going through the driver. Again, knowing that the driver would go from the alternate LAB in this case to alternate color space LAB to RGB, and then go from RGB to the printer. We then printed through the EFI RIP. The colors that were defined as default showed up in the EFI RIP using the internal library. So you can see here at the top where you see Pantone 646. It was mapped using this internal library to EFI's definition of what Pantone 646 is. The editable spot colors that came in had custom names, and so it picked up their alternate colors. And you'll see that here's where we see those LAB values that were part of the alternates from Illustrator. We did an analysis to the book in a light booth, looking at visual, and then also using our X-Rite exact spectrophotometer to compare between the printed piece and the book. And then we use the ChromaCalc tool, which is a free kind of engineering tool that we built here to help us with LAB iteration. You can really do the same thing in a spreadsheet, but we just kind of made it a little bit easier there for you to do. And we use that tool to try and iterate them as close as possible. So let's look at the initial results. So this was just taking the Illustrator file, loading it into the RIP, making sure the correct profiles were selected and that the spot colors were recognized correctly in the RIP, also printing through the driver, and then looking at delta E result back to the book itself. So the top number is what was the delta E from the print out of the driver to the Pantone book itself. And you can see we have a 3.5, 7.2, 6.2, 9.7, and 4.5. So again, kind of continuing the discussion from last month's webinar, if you really want accurate color, you have to use a RIP. You really can't do it with just any old driver. In the case of the RIP, we had really two colors we were trying to match. One was just using the internal EFI RIP library for spot color, and that was the case where it used the name and did that named color lookup. And then the second color is where we actually typed in an LAB that we measured from the Pantone book itself, and went ahead and print that. And you'll see that there's some results there. When I just look at some observations of everything on the screen, what jumps out at me? Well, the first thing is if I look at 199, I see that the delta E for the RIP library and book LAB are very close to one another. This is telling me that likely the value defined in the RIP library is very close to what I measured in the book itself. But if I go down to Pantone 155, I see a huge difference between the RIP library and the book LAB result. And that's probably indicating to me that the value in the EFI RIP library itself probably isn't accurate to the book I have. And that either means that the library value in EFI is off or my book is off. But either way, if my customer is going to look at my book to pass the color for a visual match, I better make sure that I'm getting as close to the book as possible. And you can see the opposite happens as well, where on 361, which is the green, the RIP internal library nailed the color delta E-wise right out of the gate to the book, but the book LAB that was typed in is actually further off. It should be noted that a lot of the delta E's on the screen are really, really good delta E's. The check marks, by the way, are my evaluation in a light booth of how well the printed piece visually matched the spot color library itself. And so 199, even though it had a really pretty good E, a 1.5 and a 1.8, it wasn't as saturated as the book. It was just enough off where it wasn't something that was approvable. 151 was not a match, and the 7.0 and the 4.8 are indicative of that. 646 was not a very good match at all either, and either for the RIP library or the book, which was interesting because if you have 1.7 delta E, and going back to the webinar from last week, most people would call that good. But visually, right, it wasn't really close enough for us. 361 was a great match, and 259 was a great match as well. So even though some of these delta E's are really good, this 1.7 is really good, this 1.8 is really good, we decided to go ahead and iterate this. And the way that we went and iterated them is we used this tool called ChromaCalc. And really all ChromaCalc does is the simple math to basically edit the LAB values in order to try and dial them into the target. So we typed in the target value, which we got from measuring the Pantone book itself. We typed in the measured result, what was on the print. It gives us new color values. We set those, and then we would go back, in this case, into the EFI RIP, because it's really easy to edit LABs in the EFI RIP, and we would just type those in and print a new result. It should be noted that lots of RIPs have ways to iterate the LABs. EFI has an automated iteration tool built in for their spot colors as an example. But the challenge becomes here is that when we don't trust that the internal values are matching the physical book we have in our hand, a lot of times those iterative tools aren't help us, and we're left to manually iterate these. Also, a limitation of iterating using the ChromaCalc process that I'm talking about, this is a one at a time iteration process. So I'm editing one color at a time to match the book. One of the nice things about the EFI tool or more automated tools is that they'll iterate lots of colors all at the same time, making it a lot easier to do. So we started with Pantone 199, that was our red. We started at a 1.8 delta E like we saw on that last slide. We did one iteration and we ended up with a 0.7 delta E through the EFI RIP, iterating the LAB using ChromaCalc, and we thought it was a much better visual match, even though it was a really small change. We also wanted to iterate 646. The delta E on this was 1.7. We didn't feel like it was a good visual match at all. We went through one iteration on 646, just tweaking the LAB values, The delta E came down to 0.5, and it was a much better visual match, as you can tell by the sample here that we've seen. So I won't go through all the results, or I won't show you each individual one, but we did go through and iterate all 5 colors. And what was interesting is that we see that in all cases, even though we had really good delta E's, we were able to bring the delta E's really, really low with really just 1, in some cases 2 iterations of the LAB values. So if you have a spot color that's a critical match, this is a great methodology for dialing it in, not just to match some value that you have, but to also visually match it to the book. Notice 151, so this was a color that it ended up being out of gamut for us. So we started at a 4.8, and no matter what we would do, we could iterate it and iterate it and iterate it, and it really never changed. And that's a good indication that your color is out of gamut. So for an out of gamut color, though, 4.5 isn't so bad, but again, it was still a visual fail. So that's really the point of the seminar today, or the webinar today, is to just talk about what are some of the challenges, and then what are some quick tools and tips that you can use to try and get colors that are coming out of your RIP with your printer and your inkjet media that you're loaded, get those closer to the visual book that you're using when you're showing your work to your customer. Some resources that we offer, if maybe this is, maybe we expose something to you that was of interest, and that you say, I want to learn more about that, or how can I personally walk away and improve my workflow? Some resources for you. We have the eColor Expert, service, which, as we've explained in previous webinars, is open to anyone who uses validation media. If you're a validation media user, you have the ability to take advantage of a promotion where we will help you profile your media in whatever form that takes. So you get assigned a personal eColor expert to help you through the profiling process, or the color management process. There are some test files that you can use. The test file that I used here in this webinar is called Edit Spot Colors Test PDF. And we're going to share that out to you right now. So if you see in the shared files window in the lower left-hand corner, you have the ability to download that PDF right now if you'd like, and you can use that to do your own testing. And also, we're offering the ChromaCalc tool free of charge to anyone here at the webinar. Just need to stay tuned to the end, and we're going to ask a question for us, or submit a question to us through chat, so that we can get you your free copy of the ChromaCalc software. Also, I do want to mention that we do partner with Winit, who is the exclusive distributor of the validation media. And right now, Winit is offering a promotion that if you buy a roll of validation media, you have access to the eColor Expert program, as I mentioned a moment ago, but you're also eligible to earn a 25% discount on selected, or on select X-Rite gear, either software or instruments. And if you'd like to learn more about that program and how to get a discount on purchasing some X-Rite color management tools, you can contact Winit at the number on your screen there. Excellent. So I'd like to thank you for coming today. Hopefully you learned something new about spot color management, and if not, hopefully you'll be kind in the questions section. I know we did get some questions that came in during the webinar. I'm going to address those now, but I'd also like to invite you, if you're interested in the ChromaCalc tool, in the chat, please simply let us know if you'd like a Mac version or a PC version of that tool, and we'll be sending those out. We'll send a link out to those to download that application later this week. Let's see if we have some questions here. So, yep, we have one question. How do we color manage tint colors is the question. So that's a great question. So many of the tools, notice that we just color manage solid colors. Many of the RIPs that are available on the market give you the ability to also specifically manage the tint values of a spot color. So those tint values can typically be managed one of two ways. The most popular way and the easiest way is to simply put a dot gain value in it. So if we say that 100% of Pantone 151 is some LAB value, typically a 50% of that same spot color would simply be half of that same LAB. It's a very simple process. You can go in and say, well, no, I want to put a dot gain curve on that. And what it will do is it'll use a curve to kind of add weight or take weight away from that spot color as we get to some percentage of it. A more advanced way of doing it that many RIPs will offer is the ability to add an LAB characterization. So now you could go and measure 100% of the spot color like in the Pantone guide, but if you actually had a printed ramp of that color, you could then also measure, let's say, the 50% of that spot color, get the LAB and type that in. So you have the ability to define each tint as an LAB color. Again, it's a manual process. It's not, and you'll find that as you look at advanced color management features for spot colors, much of it is a manual process in order to dial things in to get it as accurate as possible. Thank you for that question. I think that's the only question I see, so we're going to go ahead and wrap things up. Again, thank you for joining. Stay tuned for our webinar next month as well. We'll see if we're going to stay on the spot color track or not. It's open for debate. If you do have some recommendations or some suggestions for webinar topics, we would love to hear from you. And also, don't forget, if you want to get a copy of your of the ChromaCalc tool, to please tell us what platform you want, Mac or PC, in the chat window. And thank you for attending this FineEye webinar on spot color management in large format inkjet.